Okay, so here's a from the ThinkDO textbook. This is the second example in Think Goodness of Fit section in chapter 11. And what's a little different about this one is they aren't assuming that all the frequency, all the classes, that they aren't assuming that everybody, that these blood types all occur at the same frequency. There's different percentages. You know, most people are O positive, it's showing us. So that's that. I'll actually set this up as if they're all the same, just because I don't know if some of you might need some help with that kind of question. But so for this one, we have to calculate our expected frequencies here. So what I did is I went out to a spreadsheet. And where's my spreadsheet here? Here it is. So here's the observed. Now, one thing I don't know if they told me that in the text, but I'm just going to add up. I don't know how many people this represents, so I'm going to find the sum. So there's 800 people in this sample. So we have to find what 38% of that 800 is, and that would what we would expect to see. So on a spreadsheet, I don't know how much you've used a spreadsheet, but if you do equals, that'll tell it you're going to do a formula, and I'm gonna do 800 because that's how many people are all told there are. And I'm going to multiply it by that proportion, by the expected proportion. So that's going to take 800 and times by 0.38. You can certainly just do that by hand on a calculator, but I'm going to let the spreadsheet do it, because if I fill down now, it automatically does that for me. Okay, see, it takes the 800 and times it by whatever the proportion is. Just to make sure you said, in case this is new to you, so I typed in the first formula, I pressed enter, I went back to that formula, and you see that little square? When I put my cursor on that little square, see how it goes to a plus sign? And that lets me fill down, that lets me drag it down, and that'll fill it in. So that's our expected. Now, as far as that applet, let's see here. I might break that out to a new window just so that I can, this applet here, and you can find these anywhere to get the, there's a lot of different versions of this. A graphing calculator does a great job with it too. So here's my spreadsheet with my values, and I'm going to have to type those in. I've got an observed frequency, and did they let me change the value? Did they let me change this? I don't know. Oh, they do. Well, let's do that. I don't think that this doesn't matter. You don't have to change the values to get the chi-square test statistic. But since I'm here, let's do this. A plus, A minus. I don't think I know anybody with type A or type B. I think almost everybody I know is positive. I mean, type O. Let's see. Then AB positive and AB negative. There's another one I found that will do up to 12 different versions of this. I had 12 different categories. This one does 8, so that's okay. And then we're going to type in our observed. What do you get? 310 and 71 and 235, 64, 68. I'm going to make this video a little bit longer after I do this, and we're going to calculate this by hand also. Okay, so one nice thing about this calculator, I think you can just type in the expected frequency, the expected proportions. That's what's going here, the expected proportion, and it'll automatically calculate it for you. But since I've already done those expected values, I'm going to type in 304 and 56 and 272 and 48. Most calculators want you to type in the expected. They won't do the calculation for you. 72 and 16 and 24 and then 8. And what else is this calculator asking us for anything? I don't think it needs anything else. So we're going to calculate it. Here's my chi-square number, 23.72. There's my degrees of freedom. There's my p-value, very small p-value. I guess I should go back and look at the problem now and see. Test the claim. So there's the claim that this group doesn't fit the national distribution. So that's H1 is what I would do. I would say HO is they do fit this distribution, and any difference is explained by random chance. And then H1 will be it doesn't fit the distribution. So then I come back and I would write that down, and then my calculator gave me a chi-square number. That's my test statistic of 23.72. I could report the degrees of freedom. That won't affect things here. And then there's my p-value, so a very small p-value. That p-value is less than 0.01, less than 1%. So I'm going to reject HO. And then to make a claim here, just a minute here. I've got my flow charts all online here. Let's see. HA is the claim, and I rejected HO. So how I would word my conclusion is the sample data supports the claim that the distribution of blood types in this group of people does not match the national proportion. So something's up, something's different. What they aren't telling us. Let's make sure I answered all these questions here. I tested the claim. What did they get? Did they show me the test statistic? Yeah, you don't have to. When you're doing chi-square tests, you don't have to write this out. You can just say, in English, the probabilities do equal the national proportion or something like that. You don't have to write out all those P's. And we don't have the answers, do we? But we do. So that's how you do a chi-square test with more than 4, more than 5. It's all the same. Now I should calculate chi-square by hand for this. It's not hard to do, and I'm not saying you have to. I want you to be able to use the applet, but it's not hard to do that by hand. If you come back and look at the table, we have to do this calculation: the observed minus the expected, square the difference, divide it by the expected, and then we find the sum of all those numbers. So I'm on my spreadsheet here. Let me come back here. So I'm going to do the O minus the E part. So equals, let's see, there's the observed numbers minus the expected number. And I'll fill that down. So that just took the 310 minus the 304, the 71 minus the 56, etc. Then the formula asks me to square these values, square these differences. Let me so what I'm going to do is I'm going to square this. So I'm going to square that 6, times it by itself, right? And then my next column is the squared differences divided by the expected value. So the O minus the E squared divided by E. So equals, there's my squared difference divided by my expected value. And now I'm going to do that for all of them. And now I'm going to find the sum. That's just my chi-square number. And notice I'm getting that 23.7. To get a p-value, if you're doing it this way, to get a p-value, I'll have to use some kind of calculator, or we could do a critical value of chi-square and test it that way. If we go to ThinkDO, let's see, I believe they give us a chi-square. Yeah, here we go. So I know I've got 7 degrees of freedom, 7 degrees of freedom because there are 8 categories. And if I'm going with a 1% level of significance, 7 degrees of freedom, I said, There's my critical value of chi-square is 18.475, and I had a chi-square value of 23, so it's in there. It's going to be in the rejection region. Reject HO. Same conclusion. Okay, so that's how you do a chi-square test, a goodness of fit chi-square test when there's more than 4 variables, is what the question was. Okay, so I hope this helps you out.